Hello YouTube, today at usbcrepair.com we got a Dell Inspiron 7306 USB Type-C board. The jack itself is USB Type-C connector, which is supposed to be broken, as what the client says. This should be relatively straightforward, but this is the first time I see a model like that here. So I figured I would make a video, and that's a replacement connector for it. Thing is, I don't have the replacement connectors for that board in stock, so if you decide to send us this motherboard, send us an email stating that you're shipping out this motherboard so that we can order one of those connectors for your motherboard, all right? So let me show you how I'm gonna replace this connector right here. All right, so what we got here is the top view of the broken connector. As you can see, something isn't right with the rear pads already. I need to get the gloves on to make sure that, let's see. I already insulated the area around the connector so that I would have space to work with. So you see right here, ooh, that shouldn't be like that, but I mean this pad right here is already off the motherboard. The success rate on USB Type-C connectors depends how many pads are ripped off the connection here. If all of them are ripped off, I'm not even gonna bother, simply because it's just too much work, and the flat rate fee that we charge is not gonna do it. I mean, we usually charge a flat rate fee. The prices are again on usbcrepair.com. Ooh, what's that? How is that possible right here? Let's take a look in 3D. Yeah, I mean, I'm not sure what happened here, but something happened. Anyways, so I insulated the area around so that the hot air, when I'm gonna blow on this guy, the hot air not gonna take out all of the... you know what? Here's what I need to do first. Here on the bottom, we got the connections through the motherboard for the inner row. And that's a good thing, because when you got the inner row, those connectors usually gonna work fine if you have inner row of connections. So the goal here is to add some solder to those pins, to the pins right here, so that instead of the pins from the jack being stuck in the holes, the connector gonna come out together with the pins that belong to the jack. Otherwise, you'll have a long time here trying to get all of that stuff out of there. So what we do is we added some flux. And now what we're gonna do is this right here. We're gonna add the solder to the soldering joints. How you add it doesn't really matter, because I mean, as long as you flood everything with the new fresh solder. I'm adding the leaded solder. It's toxic, but it melts under lower temperatures than the lead-free solder, like the ones that the connector is soldered with right now. So what I'm done here, I added the solder, dropping the melting point for the future. We flip this guy over. What I want to do is I want to add some solder here as well. Now it doesn't work for me, because I need to add more solder here and more solder right there, right here. I'm using this microscope because I specifically spent thousands of dollars on this microscope for these particular connections, for the USB Type-C connections, because it gives me a 3D view of the soldering joints. Now we're using just the top view, but I almost always use the 3D view, and it's much better when it does 3D view, but here I just need to add some solder here and add some solder right there. All right, like that. Good job. All right. So what I want to do next is add some flux to the rear, top, and the next thing is to fire up the hot air station at around like over 400, basically around 430 or so. And now what we're gonna do is just gonna warm up here, and we will try to melt it from this end. Strange, doesn't want to melt. I should probably increase the temperature just a little tiny bit. I just want to melt the components on the jack itself, not so much the board around it. Come on. All right, as you can see, that did come off. And all of the legs from the jack are right here, which we're just gonna take off like that. All right. Now what we're gonna do is we're gonna switch to the top view. You get a much better view here. We wanna remove all of these pins. And what we wanna do is we wanna make sure that hopefully none of the pins got stuck inside here. All right, so the next thing to do is to clean up. So again, only one trace is missing, which is no big deal. This is probably some sort of data signal, which is, it can leave. The laptop should power up and charge without it. All right. All right. Right, what's tough is to get the camera to focus when there is so many shiny objects around. So what I did was I added some flux, and now we're gonna just clean up everything around here. Alrighty. Alrighty. All right, and right now I just want to check every single one of those. All right, under the microscope, you can see that some of the holes are not empty yet. So the goal is to, again, run the cleanup process a few more times. As you can see, some pins are still stuck inside, like the two right here. Let me see if I could just clean up these guys here, right there. Well, and that's what the reason why you're paying so much for the repair, because it takes some time to get every one of those pins out of the holes where they got broken and got stuck in. So yeah, I mean, that's gonna take me like at least like 10-20 minutes to go through every single one of those holes. All right, let me not bore you with the cleanup process, because it's gonna take some time. Alrighty, so 20 minutes later, you could see that every one of those holes is nice and empty, and including this one. This one just has the foil from the back. Clean, yeah. So now that everything nice and clean, what I'm gonna do is obviously put the new connector on. That's the new connector here. And let's see if it's gonna solder beautifully. Alrighty. It should pop right in. If you need to use a force, this is probably not something that was desoldered properly. Let's see if it's gonna get right in. Will it or will it not? Assuming that's the right connector. Beautiful, beautiful. Yep, we got right in. Yep. All the way in. Yep. Looks good. Let's take a look right here, a little bit to the side. A little bit crook to the side, so let's straighten it out. Like that. Okay, good job. Let's take a look on the bottom. Well, shoot. That's not exactly what I wanted. What I wanted to make sure is all the pins went through. Pins looks nice and straight, except maybe this one. No, it's all good. All right, let's try it one more time. Put it right in. Straighten it out. And let's add some solder to keep it nice and steady. All right. Let's bring this guy over this way. All right. Listen, I need something to keep it like that. Like that. Like that? Okay, good job. Good job. Keep the pressure on. All right, did it move or it didn't move? All right, so you want to apply downward pressure. And this iron will grab. Okay, looks good. Looks good. Wonderful. Now what I want to do is the same thing on the other side. And the other side seems to be slightly more lifted. Is it lifted? No, it's not lifted. It's good. All right, let's do the other side. Good job. And good job. All right, so I see now that everything's nice and stable. I can work on the pins on the bottom. Let's see, pins on the bottom. Oh, by the way, you see that every single pin is straight through the motherboard. To make my life easier, we're just gonna use a whole bunch of flux here. All right. And let's solder this guy up. All right, like that, like that, like that. And like that. Good job. I'm not sure when was I stopped recording, but now I was working on the top side and I got a huge breach right here, which I'm trying to debreach like that. Let's see. Nope, it didn't work out. Let's try one more time. Nope, it didn't work. All right. So you see, that's the reason why it costs so much, because stuff like that takes forever to correct. Because you see, the solder got stuck in there, and there is really no easy way to get this solder out of there. Nope. Nope. And no. Okay, here we go. Now, is it bridging with the top now? Or it's not bridging with the top? And this is a 3D microscope. Can you imagine how hard it is to do in just 2D? All right, let's see. Like that, like that. Okay, I just want to go over each one. Again, this is the ground pad, which is huge, which is probably not gonna be heated up here in any way, shape, or form by my $1,000 soldering tip. I mean, soldering iron itself station. Yeah, no way to heat up this huge pad. I mean, it's like entire motherboard you need to heat up in order to solder that guy. Let's see if it maybe got a little bit solder on it. Let's take a look. Nope, we see it moves. This is fine. No, this is also moving. No, just this one moves because there's nothing to solder it to. This one is fine. I'm not sure about this guy. Is there? No, this one is soldered fine. All right, so my only goal here is to deal with this guy. And I don't see that this needs to be soldered for sure. So, because that's the ground. I mean, without this ground, nothing gonna work. All right, so the goal is to flux everything here and see if we can shove a huge iron in there. Probably not, but what if? Can we? Or we can't? We can probably hit up pad here. All right. We can hit up pad right here. And once we heating up the pad there with one soldering iron, we can use our other hand to solder this guy up. That way the pad is heated and this guy should be heated. All right, so let's see if my trick on this motherboard worked out or it didn't, using two soldering irons. Let's take a look. Where is the... Yep, and that did work. So what you do is you heat up this pad, which is also ground. This is all ground, this ground, this ground. It's all the same pad. And then what you put, you bring a smaller soldering iron here, and you heat up this guy, and everything gets soldered properly. Okay, so let's clean up this mess. You see how all nice and beautiful everything is. And then we're gonna test and see if... All right, so what I'm doing is I'm flooding things out here. Let's try the other end. All right, let's do this guy here. All right, almost. Ah, wrong. No, not wrong. Everything's correct. Here. Where all the flux came from. All right. Come on. You see, when you're not in a hurry, you can do a beautiful job here on the bottom. And pretty much the top as well. All right, so do a good cleanup. And everyone asking why are we charging more for USB Type-C repairs instead of how we charge for the regular connectors repair. And the regular connectors have just like plus and a minus. This guy has 24 pins, trying to remove the old one. But the biggest deal here is to make sure not to mess up anything on the motherboard, because everything just keeps flying off the motherboard here if you're not insulating it well enough. All right, those are the lint-free pad, which is supposed to absorb all of the dirt and alcohol. And at the top is the Q-tip, which does everything nice and beautiful. All right, so I will dry it out and let's test it out and see if it's gonna work. All right, so the most important part is if you're doing it yourself, you see those black filters here, this filter, that filter, this filter, and that filter. If they fly off the motherboard, nothing gonna work. So that's the reason I'm stressing that you need to insulate everything here. Insulate everything really, really well. All right. And don't short anything. So that's the reason why everything needs to be dried out. So that when you put it under power, here on that side, we got pretty much, here, let's see what we got on this side. Yeah, you see we got filters here, but they're towards the back. And those are not the filters here. All right. Good job. No, I mean, we still got some flux remaining residue right there. All right, good job. All of this alcohol needs to dry before you're gonna test it. And the only way to dry it is not blowing the hot air on it, because the hot air will take out every single filter of the motherboard. Filter comes off at about 100 Celsius. And you're not gonna be like those two, 1, 2, 3, 4, 5, 6. You see how kind of on the angle they are? They just come off from overheating. Okay, so the moment of truth. All right, everything seems to be nice and dry. We're gonna connect the USB tester. Not sure if this is a new tester or it's not the new tester, but let's see. I go through those testers every like once a week because they just fail on me all the time. All right, so let's see. And we get 20 volts on that side. Flip the switch over. That's the other side. And we get 20 volt handshake right there. So it's good. I don't want to overheat the CPU. That's the reason why I disconnected early. All right, so the job is done. Thanks so much for watching. Please leave a like, subscribe, and take care. Thanks. Bye.